This Zoom session is being brought to you by the fractal squared circle. All right, now for today, we'll be covering inverse trigonometric functions: inverse sine, inverse cosine, and inverse tangent for 3, 1, inverse cotangent, inverse secant, and inverse cosecant for 3, 2. The inverse sine is basically inverse of a sine, as you might expect. Well, okay, actually, it's this graph here, this one here. Now, if I wrote the graph of x equals sine y, it would go upwards, wobbling up around the y-axis like this, but that's not a graph of a function. So I take this little piece of that, and that is called the inverse sine, written sine minus 1, also called arcsine. I'm not really happy with this -1 notation because it looks like a reciprocal and it isn't. But all right, so y is arcsine of x means it's sine of y equals x. So you can draw a picture of it here. Here's an angle y. Here's a distance x, in this case negative. I want to know where it meets the right half of the circle, and y is the angle that reaches that. Now, okay, this angle here would also have a sine of equal to y, but that's not the branch of the function we're using here, so it's this. All right. Sine of arcsine is always equal to x for x between -1 and 1. In other words, really for any value of x where arcsine is defined. Arcsine of sine is for x is between minus pi halves to pi halves. Beyond, it gets more complicated. Arc cosine, well, if you take the graph of x equals cosine y, it would be a wobble going up and down the x-axis, the y-axis. So we take this little piece of it, and that is a function graph like this. Arc cosine written like this, or cos inverse. Y is arc cosine implies that cosine y equals x. Here, y is going to be between 0 and pi, between 0 and pi radians. Look for, and we want to find the x is say a horizontal distance. We draw this vertical line over here at x. We want to find an angle y, which is the upper half of the circle at the vertical line x. Arctangent, y equals arctangent of x, written tan inverse x, means that tan y equals x. If I wrote x equals tan y graph, it would be a bunch of S curves going up the plane like this. We take this branch of it, and that's the graph of the arctangent. Arctangent is between minus pi halves and pi halves. So here, what we imagine is a circle. We go distance x. Here's a distance 1. So x over 1 will be tangent of this angle y, and that's the arctangent. So, for example, arcsine of -1. What's that? Well, I lower a graph to the line of y equals -1, and it meets where does it meet the right half of the circle? It meets it here at -90 degrees, or in other words, minus pi over 2 radians. Arcsine of √2/2 is what? Okay, well, we look for an angle between minus pi halves to pi halves, whose sine is √2/2. So here we draw a right triangle. This side is √2, this side is √2, this side is 2, a 45-degree angle. So this angle is 45 degrees, or pi over 4. Here they asked to just find by calculator what's the arctangent of -0.4. So it works by calculator, but you must make sure that the calculator is in radian mode rather than angle mode, because it will give two different things. Arctangent of √3, what's that? Well, you go over 1, go up √3, over 1, up √3, diagonal 2. This here is a 60-degree angle, which is pi over 3 radians. Here they're asking for arcsine of -0.12. Again, we can use the calculator in radian mode and get -0.12028.9, etc. This one is a little unfair. Invert f of x equals 5 sine x plus 2. Well, as I noted, the arcsine is really only a branch of x equals sine y. So really, there are infinitely many inversion ways to invert sine. But I'll do the main one. So to invert f of x equals 5 sine x plus 2, I want if y equals f inverse, then f of y equals x. So put y in here and get 5 sine y plus 2 equals x. Then proceed to solve for y. You subtract 2, divide by 5, sine y equals x minus 2 over 5. And then, okay, arc sine of that. It's one of many solutions, so I'll accept that. Arc sine of x minus 2 over 5 is the inverse function. Here, solve for sine arc sine x equals pi. Okay, first we transpose the 4. Arc sine x equals pi over 4. Here we can take sine of both sides, and it'll be x on this left side, no problem. So it'll be sine of pi over 4, and that's for 2 over 2. Solve. 4 arc cosine x minus 2 pi equals 2 arc cosine x. Well, okay, first we move the this 2 arc cosine x to the left and move the 2 pi to the right by adding 2 pi to both sides and subtracting 2 arc cosine x from both sides. So you get 4 arc cosine x minus 2 arc cosine x equals 2 pi. This simplifies to 2 arc cosine x is 2 pi. Divide both sides by 2. You get arc cosine x equals pi. Then take cosine of both sides. X equals cosine pi, and cosine pi is negative 1. That's x. Okay, that concludes that part.